Okay, I think if we have all our speakers in the room, I think we can make a start. You happy, Reese?
Absolutely, take it away.
Great. Okay, welcome everyone to Engineering for the Energy Transition. This is an event put on by COP26 and Beyond and Global Engineering Futures to mark World Engineering Day for Sustainable Development. So it'll be running for 2 hours, and we'll go through the agenda in a minute. So a reminder, if you could keep your video and audio off for audience members to start, please. This event is being recorded and we'll publish it online afterwards, along with the slide pack that I'm currently looking at and all the links to all the organizations. So in terms of a brief agenda, starting now, we'll have some introductions. At 10 past, we'll start our panel discussion. At about quarter past 3, we'll have a Q&A. Please, throughout the event, submit your questions. There's a Google form that we'll be putting up in the chat, and throughout the event, please put your questions in the chat, and we'll have an opportunity then for you to ask them or to be read out by Reese. At 3:30, they'll be going to some breakout rooms, an opportunity for networking, and we'll come back into the same meeting at 5 to 4 for some closing remarks. Okay, in terms of your host, my name's Ed Wilson. I'm from COP26 and Beyond. So we launched on World Youth Day last year. COP26 and Beyond was set up with the aim of informing, engaging, and inspiring young people in the fight against climate change. Using our experience in energy and environmental law, education, and engineering, we provide online resources and organize events to demystify climate change and suggest new and practical ways in which committed young people can make a real difference in the build-up to COP26 and beyond. And I'm being helped today by Reese.
Yeah, I'm Reese from Global Engineering Futures. We were formed to essentially champion engineers towards sustainable development. We aim to catalyse positive change by bringing engineers and employers together through both our events and the Global Engineering Network, which I'll send a link to later on. We strive to foster problem solving and creative thinking through our competitions on a global scale, bringing together early career engineers from diverse backgrounds to promote social change. And we believe that diversity and inclusion in engineering is embracing all cultures, experiences, and capabilities to generate solutions to the world's most pressing problems.
Brilliant. And we're also being supported today by some great organisations who've helped us set up this event. European Young Engineers, E2E, YGN, and the IChemE Early Career Committee. So thank you very much to them. So we will... today's discussion, is all about engineering for the energy transition. And energy transition has been defined as the change in composition of primary energy supply, gradual shift from a specific pattern of energy provision to a new state of an energy system. And the task kind of facing society is to drastically reduce our greenhouse gas emissions to avoid catastrophic warming of the planet. To do this, we need to transition away from burning fossil fuels towards cleaner, more renewable forms of energy generation and energy usage. And we need to do that transition fast. So today, to mark World Engineering Day, we'll be discussing the role of engineers specifically in this transition. And lucky for you, it's not just me talking at you with a slide deck. We have an incredible panel of speakers today. So I'll briefly introduce all of them. Dr. Andrew Garrad is one of the pioneers of the modern wind industry. He's been working on the engineering and mathematics underpinning wind turbines since 1979. He founded Garrad Hassan in 1984, which grew to become the world's largest renewable energy consultancy. Andrew is a fellow of the IMechE and the Royal Academy of Engineering, former chairman of the British Wind Energy Association, now Renewable UK, and president of the European Wind Energy Association, now Wind Europe. He has received numerous accolades for his work, including a CBE in 2017, and he became visiting professor of renewable energy at the University of Bristol in 2019. Uchenna is a chartered mechanical engineer with over 12 years of experience working on engineering projects. Originally worked on oil and gas projects off the coast of West Africa and in the North Sea before transitioning to the clean energy and renewable sector. He is now a senior project manager for Iberdrola, Scottish Power Renewables, working on offshore wind projects in the UK and Europe. Uchenna is also very knowledgeable in emerging hydrogen technologies, especially on the potential for integrating offshore wind projects and green hydrogen production. He's also completed an MBA from the Imperial College Business School of London. Henry Preston is a physicist, and since graduating from Queen Mary University of London in 2016, he's worked for the National Nuclear Laboratory, evaluating nuclear fuel and graphite cores from the UK's advanced gas-cooled reactor fleet to ensure continued safe operation. Primarily focused on underwater inspection of nuclear fuel, he has been leading innovation projects to implement new techniques and digital solutions. Henry was part of a team that came runners-up in the 2018 Spark contest, writing on the energy transition, and was awarded the National Skills Academy for Nuclear Scientific Graduate of the Year in 2019. He is a member of the Institute of Physics and helped coordinate outreach for the Nuclear Institute's Young Generation Network, the YGN, as an editor for the Nuclear Future Journal. Moving on, Yasmin Ali is a chartered chemical engineer and has worked across the energy industry in oil and gas, coal-fired power generation, district heating, hydrogen, and energy efficiency in industry. She is also a prolific writer and presenter and has written about engineering and energy for the BBC, Huffington Post, and the Metro, as well as presenting on various BBC radio and TV programs. The Women's Engineering Society has recognized her work communicating about engineering, and she was given the Young Woman Engineer Award in 2013, and they more recently named her in the top 50 women in engineering sustainability. Professor Piers Forster is an atmospheric physicist and has been a professor of climate physics at the University of Leeds since 2008. He's a highly cited researcher, a member of the UK Climate Change Committee, and the founding director of the Priestley International Centre for Climate, as well as a lead author with the Intergovernmental Panel on Climate Change, the IPCC, where he's currently coordinating the writing of their 6th assessment report. He's also a member of the Rolls-Royce Environment Advisory Board and an expert on the effects of aviation on the climate. Dr. Daisy Thomas works for 3Datix Corporation as a lead automotive research engineer. Daisy has over 5 years' experience in automotive emissions research with a PhD in engineering that focused on real-world emissions from hybrid vehicles and the impact of biofuels from the University of Leeds. Her research has explored climate solutions in the transportation industry that work alongside air quality objectives. Thaddeus Anim-Somuah is a chemical engineer working as an engineering manager projects at Croda. Last year, he was listed on the Forbes 30 Under 30 award for his work in the engineering industry. Thaddeus also has a role as European Young Engineers Vice President and as Global Engineering Futures Advisory Board member. He's passionate about sustainability and is part of the team leading Croda's global decarbonisation roadmap. And last but not least, Laura Hepburn is a self-described career chameleon, having studied future design at the Teesside University and then innovation at the University of Oxford. Laura worked on feature films and TV production sets before becoming a founding director of Greenology, a UK firm that works on innovative solutions to complex plastic waste problems, from tyres to wind turbine blades. Another prolific award winner, Laura was named on the Northern Power Women Future List in 2020, was named the Renewables Energy Association Young Entrepreneur this year, and also named in the top 50 women in engineering sustainability by the Women's Engineering Society. There we go. Okay, so I am going to stop sharing at this point. And we are going to dive into our panel discussion. So just give me 2 seconds to shut this down. The way I'm going to go through this is we have quite a few speakers. So I don't want to kind of start down one rabbit hole first and get lost in the minutiae of one topic and miss one of the speakers. So what I'm going to do is I'm going to ask an opening question to each of you in turn. And we'll go around our speakers to begin with, and then we'll kind of open the panel discussion up a little bit more and have a bit more of a kind of flowing conversation before we get into the question and answer session. Great. I will start with Dr. Andrew Garrad. Dr. Garrad is able to hear me?
Yeah, I can hear you.
Perfect. In your career, wind energy has grown from a relatively new form of generating electricity to a very mature technology, and it kind of looks to be the bedrock of UK's renewable energy future. What do you think are the big engineering challenges that remain in wind power?
Well, yeah, you're right. I mean, when I started, I built my first wind turbine in 1971, and when I started in commercial things in 1979, I could carry a big windmill blade on my back. So that was the size of the turbines then. Now, as you will have seen, the biggest one is 220 meters in diameter. So it sweeps something like 5 times the area of Wembley Stadium. So I've been incredibly lucky to have been involved in this industry, really from, not quite from the beginning, because the beginning was probably 1,000 years ago, but in the recent era. And various things have happened. So the onshore wind, I think now, has become pretty much a commodity. So I'm not expecting to see quantum leaps in the way in which onshore wind is produced. We've started offshore is getting to be mature. You said it's a mature industry. I don't think it is yet. I mean, if you compare it with automotive or aerospace, but it is maturing. Certainly, offshore wind, fixed bottom offshore wind has not become a commodity yet. We're just beginning, and now we've just in the last couple of years seen the start of another whole area of endeavour, which is floating offshore wind, which 5 years ago or 10 years ago certainly was just considered to be an eccentric sort of hobby. Nobody was taking it seriously, and it's moved from that to being a really major bit of activity. So in the immediate future, floating offshore wind is going to attract most of the attention, and a lot of that is not the windmills so much as the coupling of the windmills with the foundations. Fixed base offshore wind will go on getting cheaper. I mean, it really done a lot. It's gone down by a factor of 3 in about 10 years, which for mechanical engineering is just gobsmacking, to use a technical term. That's going to continue. I think the big challenge for all of us is now we can generate the electricity with the wind really very effectively. We'll get other ways of doing it, the floating being one of them. The big challenge is integration and use. So generation, I think we've almost cracked. It'll go on getting cheaper, and maybe there will be major technical developments with the floating. I think the big issue, actually, I've been asked quite a few times by people of your sort of age, saying I was lucky to have been, the timing was very good. I've seen all this happen. If you're looking for something as dynamic as that, what would you be looking at now? And I think the answer is integration, and particularly storage. I think we've only really just started to scratch the surface of storage. Storage has been a holy grail for a long time, and there is now just beginning to see real progress, but still a huge range of different technologies, from hot rocks to chemicals to compressing air to spinning flywheels, pumping water up a hill. It's all there. So that's where I'm expecting to see major changes together with integration. I can go on for the 2 hours, but that's probably enough for now.
That's great, thank you. I mean, Uchenna, you're also working in offshore winds. Perhaps you'd be able to kind of explain to us what some of the challenges in floating wind. What are the challenges for moving wind turbines slightly further offshore?
Just further to what Andrew has said, I think we've really had a lot to do with the fixed foundation, and again, we've stretched fixed foundation as it is at the moment. So the next frontier for the industry is floating wind, and again, there are so many engineering challenges with floating wind, but I must tell you, one good thing is the fact that oil and gas, most of the challenges we are going to see in floating wind, we already have proven technology from oil and gas. All we need to do is get it, take the technology from oil and gas, make it adaptable to offshore wind, take care of the increasing turbine sizes, and make it adaptable to those floating thing. So because if you look at, if you're going offshore there, these turbines, like Andrew said, they are getting bigger and bigger and bigger. So the structures you're going to support, they're getting very bigger. And again, you're going to support it with something that has got nothing to fix it to the seabed. There's no monopile to drive or the seabed to hold the foundations. So those are challenges. You have the challenges to actually get these foundations floating, to keep them in place for that number of years the plant is going to be operating, usually up to 25, 30 years operational life for the plant. So you have that challenges of getting it stable, having it in place, and then achieving stability that you need in the face of all the loadings from offshore, like wave, the wind loading and everything. So it's basically an engineering challenge. And don't forget, when you're doing all this, you still have to keep your mind at the cost of things. And again, Andrew mentioned as well, cost of offshore wind is come down a bit, and we're not expecting floating wind to come again to push us up in terms of cost. We are hoping to keep on improving the cost, driving it down. So it's a pretty much of a challenge. You have technical challenge there, and you still have that challenge from the side of keeping the costs down. For floating wind. So, but again, one good thing, like I mentioned earlier, is the fact that we have oil and gas there to learn from. So all we need to do is pick all the challenges we've already seen in oil and gas floating systems and make it adaptable to our offshore wind, whilst keeping our eyes on the costs as well. So yeah,
brilliant. I mean, that's something I want to come and touch on if we have some time later, is kind of the what technologies we can take from oil and gas, and in terms of what engineers have worked in that, like yourself, who've worked in oil and gas before transitioning to renewables.
Yep.
But, yeah, thank you, that's really helpful. I'll come to Henry next, Henry Preston. So you're currently working on our somewhat aging nuclear fleet, but with new plants being built in the UK and small modular reactors on the horizon. What do you think are the biggest engineering challenges facing the nuclear industry during the energy transition?
Hi, thank you. Yeah, thanks for having me, firstly, and such a great opportunity to engage in a really exciting topic, and one that I'm really passionate about. So thanks for that. So the big engineering challenges with nuclear, both fission and fusion, they're often material challenges. So in managing how materials handle those extreme conditions of not just like irradiation, but the high temperatures and elevated pressures within nuclear reactors. So fission reactors, which is my area of knowledge, and we have the evaluation of materials that come from the current reactors that you mentioned there to ensure their continued safe operation. As well, you've got the end-of-life decommissioning of sites and the handling and long-term storage of waste materials. But I think one of the most interesting challenges, and where there's a lot of research and collaboration across the sector at the moment, is the advanced fuel program. So that's focused on producing accident-tolerant fuels. And what's really exciting about that is they'll power the Generation 4 advanced reactors and be able to withstand temperatures above 1,000 degrees. It makes them ideal for flexible cogeneration of electricity, industrial heat, and hydrogen production. So decarbonising all energy, not just electricity, which accounts for less than a quarter of energy use in the UK. So the rest is predominantly consumed as oil or gas at the moment. So continuing to solve those material challenges will be instrumental in the energy transition to achieve net zero. There's probably, however, sort of possibly bigger challenge for us engineers and scientists working in nuclear, and that's one of public engagement. So to communicate about nuclear, highlight those benefits of a proven low carbon, reliable energy source with an energy density that lends itself to minimising our impact on the environment. But also we need to listen and engage in open dialogue with the public about nuclear. Because I think for a long time, it's been a fairly closed industry and you only really hear from us when things go wrong. So we need to burst that bubble, share our success stories and talk more. So that's why I'm delighted to be part of this conversation today.
Brilliant, thank you. Yeah, and kind of carrying on that communication kind of topic, I mean, Yasmin, a lot of your work now is in communicating engineering. I mean, I was looking at your background, I couldn't pick one industry to ask you about in terms of engineering challenges. So you have a more open one. You can either pick an engineering challenge or you can talk a bit about how we have to kind of work on communicating better to the general public.
I'll go with both, I think. So I think there are two challenges for me. So picking up on what Henry just said, the whole point of net zero is that we are building a safer future for everyone. So we need to make sure that the general public and the people who are benefiting from this are on board with that transition. And it's a complex subject, but I think we can communicate it in an understandable way. And it's fun and exciting to come up with creative ways to spread the word about engineering and about energy and what's happening, and listen to what people think and feel about this. I think we shouldn't dismiss that. From a technical perspective, a lot of my work at the moment is on innovation funding for industrial decarbonisation. So I'm quite excited to see what type of innovation happens over the coming years. Obviously, global industry is a really big energy user. We pump a lot of energy into steel, cement, chemicals, and just general manufacture of products that we use. So how do we go about reducing the emissions from these sectors? And I think energy and resource efficiency are subjects that really interest me and maybe don't get enough attention. So that, those are the two things that I would pick. Yeah,
there are lots of areas kind of outside of the kind of the standard electricity generation that produce quite a lot of emissions that we do need to think about. Yeah, actually goes quite nicely onto my next question, which is around one of those industries, which would be aviation. So if I can bring Professor Piers Forster, there are a number of questions I could ask you about climate science, but if we could think about aviation to begin with, what are the big kind of challenges to the aviation industry in terms of reducing its emissions?
Well, if it's okay with you, I think Edward, I sort of prefer to put that in kind of context a little bit, just to begin with. Just because the thing I want to really say right at the beginning is that we have all kind of already kind of begun to talk about individual technologies, but I would really encourage everyone to think much kind of bigger than just one technology, and I think this is very much get back to the comments that Andrew and kind of Yasmin were talking about in particular, where we're really talking about really trying to transform our society on a relatively short time frame. So this is going to be like the next industrial revolution we're talking about. So we really have to change everything. And so there are so many opportunities, but perhaps that gets in. So this idea of integrating stuff, and what we really need are system engineers and things to really do that job. And that brings us on to this idea that to really prevent dangerous climate change, we don't only have to reduce our emissions of carbon dioxide, we have to get them all the way to zero. And the industry like aviation and agriculture, where that's a real challenge to get all that way. And so, for example, we have to be really innovative with aviation. Interesting, the kind of BEIS is really trying to support this initiative to get a net zero aircraft out there on the kind of 2030 time period. So that's an exciting challenge. But that gets at one more thing again. In fact, because we have to get all the technology out there, we are really talking about really trying to work with existing technologies. So sustainable aviation fuels perhaps could be one we could employ, but that will require extra wind energy to produce those, and kind of hydrogen and things to also come part of that. So that's very exciting to try and get that all created. The other thing is we have to invent this carbon capture. We have the carbon capture technologies, but we have to do it in scale of kind of billions of tons. So that is the real kind of challenge to do that. And the thing that I would say for the engineering community, there are kind of two things I want to say about that. The first thing is it gets back to Yasmin and kind of Henry's things that they're talking about, is that because we've got a short time to do it, we have to do it all across our society. We have to work for the kind of rich countries, the poor countries, the poor bits and rich bits of society. We have to, you really can't do it just as engineers. You have to work with social scientists and with everyone to really try and work for all aspect of society. So that makes it a real fun challenge, and you have to work with kind of artists and things like this to really make it work. And the other thing that I would just end on, because I don't think it being thought about much at all, in fact, and it touches on my kind of day job, which I guess as a climate kind of scientist, is that we are going to have worse kind of climate change to come. So we have to make sure that our engineering solutions do kind of work in that worse climate. So for example, we might have far more powerful tropical cyclones. So if you have a bunch of wind turbines far off your shore, or if you have a very good nuclear reactor on the kind of coast, it will have to kind of work in those conditions. So you have to think about that when developing these solutions.
Absolutely, yeah. There's a lot in terms of kind of adapting for a future climate world that engineers have to take into account. And there's, yeah, you're right. It is a whole society change that will have to come about. So yeah, I hope to kind of chat a bit more about that as we go through. I'm conscious I need to get to all of our speakers, so I'm going to come to Daisy next. So Daisy, as more and more electric cars are sold, and your kind of work is in emissions testing. What are the engineering challenges in terms of ensuring that the petrol and diesel vehicles that we still have on the roads are as clean as possible?
That's a good question. So as more of the vehicles that are on the roads electric, it seems clear that the greater the proportion of the air pollution coming from transport will be increasingly weighted to the highest polluters. So this is older vehicles with worse emissions abatement equipment, or those with malfunctioning emissions abatement equipment. And traditionally, vehicles are checked through a few different processes. So before any new make and model of vehicle is allowed to enter the market, it goes through type approval, which was the big weakness that caused the Dieselgate emissions scandal of 2015, if you recall. And then there's also so-called periodic technical inspections as well. So in the UK, that's like your MOT test that you would take your car to every few years, where it undergoes a test just to make sure that the emissions abatement equipment is working as it should be. So since the Dieselgate emissions scandal, the type approval test procedure has been made somewhat more robust. So there's been the incorporation of a real driving emissions test as part of the type approval procedure, which means that the vehicles or the manufacturers can't so easily sort of cheat the system or just tune the emissions equipment to only be working at its optimum levels during the test, and for the vehicle to be tuned for more higher performance for types of driving that are outside the test area. However, there are still some areas of weakness in the legislation. So something that I was working on in my PhD at Leeds for the last few years was looking at the emissions from port fuel injection hybrid vehicles. So basically, because they're a port fuel injection vehicle, their particulate emissions aren't measured during the type approval procedure. But in fact, they do produce a lot of particulate emissions when the engine undergoes engine restart. And so this is an example where a vehicle that has been produced and designed in order to combat climate change has actually ended up causing some more air pollution. And it's a real pity as well, because it would be so easy to be able to achieve both simultaneously, if only that they were incorporating a gasoline particulate filter, for example, into the emissions abatement. So there are some areas that still need strengthening on the type approval side of things. But then nowadays, I'm working more on the periodic technical inspection side. And so this as well is an area where there are significant weaknesses that need to be addressed. So at the moment, the MOT test only involves carbon monoxide emissions test for petrol vehicles and a smoke opacity test for diesel vehicles. And there's no test specific for PN emissions or for NOx, which is in the UK at least the pollutant that's causing the greatest harm to our air in cities. And so before we're able to improve the legislation, we need to make sure that we have like equipment that we can use in order to improve the emissions test within the garages that are performing the MOT tests. And so this is, for example, making equipment that's like portable enough to be able to move it quickly from one vehicle to another, as the garage undergoes many different tests in a day. And also simple to operate, so people who work in the garages can easily use the equipment without needing a PhD in order to operate.
Absolutely,
so,
yeah.
Yeah,
I mean,
I
mean, it sounds like there's you know, there will still be petrol and diesel cars, and we're thinking about that kind of whole economy moving to net zero. We do have to kind of make sure we're picking out the heavy emitters, you know, in your work. I think sounds a lot around, you know, making sure the worst case cars are picked out and taken off the roads, I suppose.
yeah, exactly.
Thank you. Have we got Thaddeus on the line? I can't see him on the screen, but I hope he's able to hear me. We'll come to him next. We've got two more speakers to get our first questions to, but actually going to think. Brilliant. Great. Thaddeus, so you're working at the moment on helping a large kind of chemical company decarbonize and working on their sustainability program. I mean, what are the kind of technologies and areas that you're excited about in your field?
Yeah. So just to bring it back, when we've been doing this whole decarbonisation roadmap to look to 2030, it's basically been quite a challenge, because you've got to consider the legacy also. You're not just going to put a new plant in everywhere, so you've got to think about retrofitting existing plants in a lot of cases. And novel technologies are extremely exciting in terms of process intensification, and you know, looking at processes like oscillatory baffle reactors, which can now, it's something that's been done on a lab scale, but you know, it's we're bringing it up to you know, actually plant industrial scale, and that is a better type of reactor. But that is a solution for when you're building a new plant. So, for instance, also replacing reactions with bioreactions, using enzymes as catalysts instead of metals, or instead of not having a catalyst in a high temperature. That is going to, you know, reduce your energy load if you can reduce the temperatures. But again, it's only part of the solution. So one of the things that's really exciting me is just innovations in kind of like heat pump technology, chemical heat pumps. So this kind of technology is what is making it more commercially attractive to do the heat integration, especially when you're talking above 100 degrees. Traditionally, heat pumps, you know, they've been used below 100 degrees. With some of the latest innovations, chemical heat pumps and so forth, they're making them more and more efficient at higher temperatures. And I think also another big part of it is just digitalization, AI, digital technology. It's helping you run your plant at the most energy efficient possible. There's a lot of energy that's wasted in plants. Believe it or not, it seems like a quick win and easy fix, but you're normally running your plant to get the best output possible or best quality possible, and you're not thinking so much about the energy, just because it doesn't cost you as much as some other things. But now bringing that into perspective, and with the technologies that we have digitally in terms of AI, it makes it easier to actually optimize for energy without losing some of the other constraints.
Brilliant. Yeah, thank you. There's some really interesting work going on in that. Yeah, kind of talking a little bit about the sustainability side. Our final speaker is Laura. Sorry, I left you till the end. But we've heard a bit about some of the new technologies and innovations that engineers are working on in the energy transition. But how important is the consideration of the full life cycle of the materials and equipment used in these technologies?
I think, first of all, I need to say a massive thank you for being part of this today. I love the diversity that we are in this group right now. I think that in itself is a massive high five, because we've got people from all kinds of sectors, and that's where we need to start. We need to start collaborating and working together. It's not just a one-trick pony. This is something where everybody needs to grow together, and that innovation as well. That's what we need to take forward from all the different sectors, the forward thinking for the future. So thank you for everybody taking part today. When we talk about sustainability, obviously one of our big drivers is not just, Thaddeus talked about it there, about these amazing innovations that we're taking forward. Are we actually looking at the wastage? And something that we aim to do within our business and our sector is to be able to reuse everything in the process. And with that transition, it's trying to encourage other people to be responsible. I think responsibility is going to be as big as sustainability, and starting to question whether these consumers, whether the producers are people being responsible for the future. And we've got people from all these different sectors here, and something we work towards is looking at the decommissioning seriously, that we have some fabulous renewable energies that are doing amazing things that are going to take us forward to net zero. But are we actually dealing with the decommissioning in a way that is sustainable and responsible? And we can build the best equipment for the future that tackles, like Piers was saying, this inevitable extreme situations that we are going to go through, and we've just seen it with COVID. If you think this is bad, look out what's coming. But that's also with these extremes of higher temperatures, lower temperatures, massive extremes. And so with that, we need to be then thinking about how are we dealing with the decommissioning, with the old recycling of what we've already got. Yes, it's great to be innovative, but are we also looking at the past? And can we use these fantastic processes to make the past better? And we can do that. And we are problem solvers, whether we're engineers, scientists, whoever we are. And we go back to, Yasmin was saying, including the man on the street. This is their decision too. They've got to be able to have an input into this process. And we go back to Henry, and he was saying about, we deal with pyrolysis, which has had a bad name in the past, but we have to educate people that some of the technology that may have had a bad name in the past has had things like AI applied, or new innovative solutions. And so the process that we go through is obviously going to be for the good, and we have to change people's opinions. Daisy picked up, I'm trying to touch on everybody's, obviously there's a few barriers here, but Daisy was also saying about how the way that we have governance and structure from the top down, that is obviously a barrier to probably everybody who's sat on here now. We need to make sure that whether it's taking some of that power and decision making away from the top and actually bringing it more localized, because how can people make that decision if they're taking it from consultants that don't work on the ground? And we need to make sure that that governance and those ethical decisions and the financing is actually been given a true voice. And so it all feeds into each other, and that's why I'm pleased to see so many faces on here today, because with those people working together, we will have the solutions for the future.
Thank you. Yeah, I think with our speakers, we pretty much cover every corner of the energy industry. I mean, at this point, we've heard from everyone, which is brilliant. And that was the aim for this opening bit. So I'd like to, if anyone's kind of itching to reply to any of the stuff we've already spoken about, we've already covered quite a lot of ground. So does anyone particularly want to kind of wade in on anything anyone else has said, or do you want me to fire some more questions? Andrew looks like he's speaking, but I think he might be muted. Reese, are we able to unmute Andrew?
I was just about to say.
Yeah. I'd just like to make a general engineering comment, because I think I know you're not all engineers, but we have been incredibly good at rising to the challenge when someone gives us the challenge. So I think, I mean, my little corner of this is renewable energy, and I feel immensely proud of what we've achieved. 39% of our electricity last year in the UK was from renewables. 15 years ago, it was 3%. You know, that is just extraordinary. But I think we're also very bad at two other things. One is telling people about that. And I think people just don't know, and it's our fault that they don't know. And to have done something so incredible and not tell anybody seems to me to be indescribably stupid. So that's something we might learn about. And the other thing is we should be much more active. We passively respond in a very, very effective way when people give us a problem. But we now need to take a much bigger lead in defining the problem. I've done a lot of work in China. Half the state council in China are engineers, and I think we have 2 in our parliament. So I'd like to make a plea, particularly because it's most of you. I think I'm probably the oldest person here. So most of you, and I think probably the audience, are much younger. And if you're engineers, then please take an active role, not just in the technology, but also in your duty to society. Being an engineer, you have a duty of society to use your education and your skills to improve things, not just to wait until someone asks you, but to actually do it yourself. There we are. That's the end of my lesson.
Right, there's some great points in there. Anyone else wants to kind of come in?
Yeah, and I completely agree with what he said. And if you link that to what Laura actually said before, in terms of representation, representing the real people that actually have on the ground experience about things, being represented at the decision-making level, I think that would really be brilliant.
Yeah, Yasmin, are there any lessons your work is kind of in communication? Are there any lessons to what we should be doing better? Should we all be doing what you do and going on radio all the time?
I think not directly related to the kind of communication stuff, which I do outside of work really, but I switched jobs and joined the Department for Business, Energy and Industrial Strategy. So this is a government department about 2.5 years ago now, and it's quite incredible just leaving the private energy sector and joining a government department. And I feel like being an engineer in that environment, I can have quite a lot of impact, and I spend lots of time talking to people who are setting up energy policy, who are policy experts, but not necessarily energy experts. And I can come in and explain things to them that they may not understand. So there's that side of communication as well. And I would encourage other people to think about, other engineers to think about a government career. It's quite good fun. It's a lot more innovative and fast paced than I thought it would be, to be honest.
One of them just commented in the chat is a civil servant policy advisor with a mechanical engineering background. So there you go. We've got some in the room. Brilliant. Thank you. Piers, is there anything we can learn from kind of science communicating? I think lots of people would have heard of the IPCC reports that you've worked on. Is there any kind of engineers can learn from that?
Well, yeah. So, the thing that we learn from the IPCC is keep on at it. It's kind of persistence and persistence. So you have to try and keep on build up the connections and the contacts, and then to keep on saying the same thing on quite quite often. But the other thing that I have learned that isn't from the IPCC so much, but it is from my job on the committee on kind of climate change, and that is it's all about the kind of timing. So you can talk to a kind of politician one kind of day, and they find your thing the kind of perfect kind of solution, and you can give them exactly the same information the next day, and perhaps they're not interested at all. So you have to have some idea of what's on the policy agenda. But I completely agree with what Laura said in her intervention. It was we are living in a very kind of centralized society with a centralized government, and that isn't necessarily the kind of best way to introduce these kind of solutions. I think it has worked quite well for the energy supply and for building renewable energy, but if you look at the solution currently, it's about EV kind of cars, it's about kind of trying to put in kind of charging, and it's about putting in air source kind of heat kind of pumps and things like that. And in our decarbonisation plan, we want to fit 2 million air source heat pumps kind of annually. Okay, so it's huge. So you have to have kind of solutions that do really work for the community, and you have to be able to kind of empower the community to make some of these decisions. So what I would encourage everyone to do is probably don't just talk to a member of parliament, but you also try to talk to them as well. But you also try and get involved in trying to come up with solutions for the community, because there are so many net zero community groups out there, and they really lack the science. So they say, oh, we want to do things, we want to change the world, but they don't have a clue what to do. They just say, oh, perhaps if we just did a bit of this sort of thing, but I just think they really need that engineering and that kind of scientific expertise to be able to make the correct choices.
Yeah, definitely. It's something we're trying to do at COP26 and beyond. That's kind of why we're here. But yeah, you kind of mentioned the community aspect a little bit. It's something I spoke with you kind of last week. Actually, Reese interviewed you. I listened to it, so I feel like I spoke to you already about it. But it's something you mentioned is the kind of as the nuclear industry and the older plants shut down, there are communities in those areas that, you know, their skills are kind of being left, and maybe it's kind of going to a few locations with big plants being made down in Somerset, for example. You know, how do we make sure we bring the communities that were, you know, working in the technologies of the last few years with us in the energy transition? Yeah, so those reactors that are shutting down, they leave sort of holes of jobs that were high skilled and high paid. So I think working to perhaps get the new reactors online, so SMRs have been mentioned, but also, you know, where possible, adapt those skills and work with other sectors, such as renewables, and utilize skills in other ways. Yeah, and working with communities, because it's actually really interesting. We think about the public perception of nuclear. Overwhelmingly, when you go to those areas that have got a nuclear power station near them locally, they're very, very supportive of it because of that high skilled, high paid quality jobs that they provide. So, you know, you need to find out, you know, engage with the public, definitely, to find out what they want and see what skills that they have. Yeah, Laura, it's something I spoke with you about as well. You know, the communities you're in, where, you know, it's all steel industry, and making sure that those people have got the skills to carry forward into a kind of more greener economy. Absolutely. I keep using the word sustainability, but it's not just the processes we go through, it's people's lives and jobs, and it's making sure that they're there for the future. So upskilling, and a bit of a sore point maybe, but a great place to put this, when they actually put in for the planning for the coal mine in Cumbria, just like Henry said, people backed it massively because it meant jobs.
Were they the right jobs? Well, questionable, isn't it? Fossil fuels. I'll leave that for another debate. But I do believe that, you know, we are going to see with this green revolution, with this green recovery, we have to make sure kids are brighter than we actually give them credit for. We have to be able to put the things in place so they can carry on being innovative. They shouldn't be scared to do that, and barriers shouldn't be in the place to upskill or change those skills. And yeah, we are surrounded by highly deprived areas or people that have been laid off 5 to 6 times. Are we putting the things in place? And if we're not, bang on that door, you know, get in that conversation and go to the top and be part of that conversation at that table to say we need to start looking after these people. And this is a fantastic opportunity. We're going to go through some really tricky, hard times, and we have to make sure that people are on board with how we actually recover from this. And, you know, this transition to net zero is a wonderful opportunity to be able to show people, not just the STEM industries that we've got, but how do we look at these massive carbon emitting sort of areas? How do we help them? We shouldn't just leave them in the dark. What can we do to apply our technology and innovation to those areas to help them get through this too? You can take something that has been processing for such a long time, like the steel industry, and apply things like Thaddeus said, the AI element, the different things we can do with composition to make these future-proof, because that's what we need.
Absolutely, yeah. I mean, we have a few people on our panel who've kind of made that personal transition themselves from working in fossil fuel industry into kind of cleaner forms of renewable. I mean, Uchenna, you're one. I think Yasmin as well. You've worked in the fossil fuel industry. I mean, how do you see that kind of personal transition? How easy is that to make in terms of being an engineer in those different industries?
If I may go first, I think for me, you know, there are lots of similarities between the area of the oil and gas industry that I worked and then the area of renewable that I'm working on now. When I was in oil and gas, I worked in the offshore oil and gas, you know, sector, like building and designing and building offshore structures for oil and gas activities. Then now in the renewable, I'm doing offshore wind. So there are lots of similarities for me. So when I bring it down to myself, it wasn't really a difficult thing for me to make. And yeah, I did, you know, a bit of upskilling and stuff to really get myself adaptable to offshore wind. But again, even if I had not done that, then I would still, you know, I would still fit into the new sector. With time, you learn on the job and everything. So what I will advise anybody thinking about that is, first of all, sit down, look at your wherever discipline of engineering you belong to, look at your skills, try to find out what your discipline is doing on the other side on renewable. If you're an electrical engineer, you've done electrical system, you know, you've been doing electrical engineering in the oil and gas, then look into renewable. What are what are the things electrical engineers do there? Again, if you are a system engineer, same thing. If you're a process person, same thing. Structural engineers and stuff. So look into those things, look at the similarities, and I can tell you, in most of the cases, you have more similarities than differences. I mean, you can always transfer that skills from oil and gas to, and you will really adapt quite easily. The same way project delivery or design processes, the same steps you need to take, all the whole stages, that's the same thing you need to do. They're the same thing. So the only big thing there, like I said, is just you knowing the specific of your discipline, how it applies to the other side. And I tell you, for most engineering disciplines, it's pretty much easy to do.
Do you agree, Yasmin? You kind of made the kind of hop yourself?
I think I didn't find it so straightforward. So I went from oil and gas into district heating and then into government. And that last move was a very conscious decision that I wanted to move and do something that was like being in government. But yeah, I think I agree with what Uchenna has said. And a lot of my colleagues from oil and gas now work in offshore wind. So I think that's quite a good, it's a good transition to make. What I find quite interesting is when I was at university, pretty much everyone on my course, on my chemical engineering course, had aspirations of working in oil and gas. And the graduates that I talk to now have absolutely no interest in that, which is, yeah, it shows you the change that's happened over the last 10 years. And I think universities need to adapt for that, because you can't carry on teaching the same courses and teaching people distillation. They have to move with the times and give these graduates what they need.
Yeah. Does anyone wants to come in on that as well? I mean, that's.
Can I just make an observation? I've witnessed the beginning and growth of the offshore wind business, and when it started, the windmill people, who were pretty good at building things on shore, thought, okay, well, this is just a wind farm that happens to be in the sea, and the offshore people came to it saying, we can do anything. You know, we're the offshore oil industry, we can do anything, and neither of them were true. The offshore oil people had a complete failure to recognize the commercial imperatives, the cost base of building 100 turbines offshore, where the capital value was much less than what they used to be doing. So for them, basically the capital costs was really very little consequence, because the capital value was so huge, and the wind people were totally naive. And it took, I would say, a good 5, maybe even 10 years for the wind people to realize this wasn't a windmill that happened to be offshore, and the offshore people to realize this wasn't an offshore thing that happened to be a windmill. It was actually a new industry, which was offshore wind, and it's now got there. And you can see it got there because suddenly the price started dropping, and in the early part of the learning curve produced an upwards pressure on cost. So the prices went up by almost a factor of 2 from the beginning, before falling by a factor of 3 or 4. And so it was very interesting to see that combination of skills. And now I think several people have recognized this in this discussion. There is now almost a stampede from the oil industry into the renewables, which is great to see. And we're seeing actually the same thing happening, I think, again on floating offshore wind. That the oil industry is coming into it saying, oh yeah, we know how to do that. Actually, they don't. And neither does the windmill industry. They need to get together and realize it's a coupled system, coupled both technically and culturally, I think. And it will eventually emerge into an industry in its own right. It's a fascinating thing to see, and it's terribly important to get, in engineering terms, this cross-fertilization, because we can both learn from each other. And we do have to recognize that it is a mutual thing rather than a one-way thing on either side.
Absolutely. Yeah, and there's some kind of, you touched on energy storage. There's some other technologies that are kind of coming into that. It'll be crucial for a kind of our future, a net zero economy. I mean, Thaddeus, you mentioned heat pumps as well. I mean, they're just kind of starting. So I mean, lessons that we could learn from technologies that have kind of made a success of themselves. I mean, Thaddeus, do you think there's a lot to learn in terms of the heat pumps?
I think there's a lot to learn in terms of a lot of technologies, actually. If we're looking at the curriculum, what Yasmin said is absolutely spot on. Every curriculum has, on several years, separation technologies. Now, what separation technologies are they learning there? That is, in every course, it's distillation. But, and where's distillation going to be the most useful? In oil and gas? Of course, you're still using it in chemicals, but as we're looking to the future, this is a discussion that I'm not just saying here today. This is a discussion that's also being had and being challenged by some of the university professors that I know, and I've also had it with several different universities and in iChemie. You've got to look at what are the alternatives. Now, distillation is often it's an easy one, but it is, for instance, high energy usage, because you're boiling everything and then you're cooling it off and then you're boiling it again on the bottom. Now, if you could do that with a different separation process, you could, for instance, membrane technology. You want to teach them that, and in membranes. There's all sorts of things that you could be talking about per evaporation. There could be reverse osmosis, whatever, but it depends on the properties of each of what you want to separate. When we're talking about the chemistries of things as well, that's where it comes down to. You have to separate because you've got to separate some raw material and feed. You've got to separate something that in your reaction, right? If we increase the chemistry load so that they understand catalysis better, and these students are coming out in the engineering, and that make that more of a chemical part rather than, you know, a modeling part, you know, that is another way to rethink how we're doing our processes. Because when you go back to the theory and you can say, actually, hey, this process, you could do it on a completely different type of reactor. You don't need to have these parts that you need to separate at the end. You could do it without it. You can even skip a separation process. I think this kind of innovative, out of the box thinking is what we need to bring in from the university curriculum, and it's going to go straight through industry as well. And of course, there's people there that have always been there that are and have always had that kind of thinking and are making breakthroughs. But I'm talking about enforcing it on, you know, on the large scale for all of the engineers, so that we all think differently and we all really push the innovative and technologies in industry.
Yeah, thank you. I mean, definitely. I mean, kind of touching on that education side. I mean, I'll come to Daisy on this as someone who moved from physics to engineering. I mean, do you think in your industry there's a lot of change going on in the automotive kind of world? You know, what would you say to kind of young engineers looking at getting into an industry that seems to be shifting? What would be your advice to them?
My advice would be to get stuck in anyway, but also just always look to be broadening your skill set and your knowledge base. So I think that, you know, there still needs to be work done in these areas, such as internal combustion engines, and so we still need this injection of new engineers and, you know, those with bright ideas, but that you should also be aware to be looking to sort of branch out as much as possible as well, so that you know, whatever technologies end up being the ones that show the most promise, you're in a position where you can sort of transition with that, so that you don't get left behind.
Yeah, absolutely. And did you find the kind of transition going from one STEM subject into engineering too difficult, or you know, was that a jump that you found you could make quite easily?
Personally, I found it very manageable. It helped that the PhD that I was doing was part of a doctoral training centre course, so it started with a master's, so I ended up doing a master's in engineering in the year just prior to choosing my PhD topic. So that was useful. I sort of got the basic skill set that was required to then continue and do the PhD afterwards. So yeah, for anyone who has done an undergraduate degree and is looking to move to another industry, for me, I found the PhD with an integrated master's was a great way to do so.
Yeah, brilliant. We have two professors on the panel, so if you've got to either Piers or Andrew wants to weigh in on the education side of how we, you know, how we educate engineers into kind of this changing industry coming up.
Speaking from kind of my perspective, the kind of PhD centre that I run currently, the whole point of it is to really try and go across disciplines. So to get engineers, to work with people like myself, climate scientists, but also work with kind of social scientists, and then people from the kind of business part as well. So sort of to try and get this solution-oriented community, then it is certainly your kind of general patient, I think, do really want that sort of interdisciplinary education. You know, you don't necessarily want to be trained just in engineering. You want access to all the kind of gambit of disciplines, because I think we do live in a world where people change jobs more frequently than they did before. You don't work for one company for your whole career. You know, you change and you adapt. So I think this idea of trying to learn from different disciplines, but I think we aren't very good at catching up. So it's good to get accreditation of things to speed, because quite often the accreditation things don't move very kind of rapidly. So it'd be good to kind of change that to make it work a bit more openly.
Piers is a proper professor. I'm just a pretending one. So I'm not sure I'm qualified to answer properly, but I am involved in something called the Cabot Institute in Bristol University, which is an interdisciplinary organization, which I've been in there on the board of it for, I don't know, 6 or 7 years now, from the very beginning. And to start with, I thought it was doomed to failure, because my experience in the past has been that academics don't want to collaborate across disciplines. They want to be the number one in their own discipline, and by working with another discipline, they're somehow diluting their efforts. And I'm pleased to say that I've been proved thoroughly wrong, that it's really worked extremely well. And the interdisciplinary activity does provide a lot of stimulation. Of course, this is at a very high level of research, but I think the same thing applies throughout the university hierarchy. And it's quite a big decision to decide to be an engineer in the first place, and then you have to decide whether you want to be aeronautical or mechanical or chemical or structural or electronic, which is also quite a narrowing thing. So I think broadening the base and allowing people to move around a lot, not just with engineering, but with all the other disciplines as well. So in the Garrad Centre, we have social scientists working with engineers, we have physicists working with economists, and it's very, very healthy. And one last little hobby horse of mine, there's a great department at the University of Bristol which is called Engineering Mathematics, which is, for me, is just perfect, because, of course, mathematics is the glue that binds us all together. So it doesn't matter what you're doing. The mathematics is the common language, and that's wonderful.
Brilliant. Yeah, I mean, I think from this, I think this conversation we've had so far, I think we can just kind of tell how important the kind of interconnectedness of all these disciplines. I mean, we could go dive down into any one of these technologies for 2 hours, but having this kind of wide range of voices, that's absolutely brilliant. Has anyone got anything they want to come in on?
Yeah, there's a reason why I think one of the SDGs is partnership, you know, and it's all about getting that collaboration, that you can just work together and get each other's ideas, you know, because, you know, actually when you start to cross collaborate, you also start to understand each other's challenges, and sometimes the social scientists might not have the solution, and sometimes the engineer might not have the solution to their own problem apart, and sometimes it takes that bringing together to make a new idea. And I think it also relates to Piers' point in the beginning as well, with the communities, that it's also very good to have within the communities also engineers getting involved there on that scale to help communities also achieve their sustainability targets. Because, you know, you need to take people along, you need the social science, you need to understand what it's about, you need kind of climate science, but you also need, you know, a how-to, you know, so we need to work together to get there.
Absolutely. I mean, I think actually our Reese might be able to chip in on this. Global Engineering Futures is kind of set up for that sort of kind of collaboration work between engineers, isn't it?
Yeah, absolutely. We're essentially building a global platform of engineers from all disciplines across all national boundaries in order to foster that kind of collaborative working and hopefully generate some really impressive sustainable solutions.
Brilliant. Right, is there anything anyone else wants to jump in on? If not, I think it might be quite a good natural break, possibly to have a quick break and then come back in a minute or two for some question and answers. Reese, if you're happy with that.
Absolutely, yeah. If you'd like to kind of stick the slide up, we'll have a quick coffee break.
Now.
There we are. I can see Henry's already dashed off.
Brilliant.
Just a 2-minute break for them to catch their breath. And yeah, so this is just the last call. In the chat, there's a link to a Google form. So if you'd like any questions asked, please do submit through there. We have had a number already, and we'll try and get through them all.
Reese, I'm not sure if you'll be able to see if Laura dropped off the call. I don't know if she's had a chance to rejoin, but it would be a shame if there were some questions directed at her that we couldn't get to. Reese, we have a question about the questions.
Shall I just answer the question about the questions?
Oh, well done. Just going to check my email to see if Laura's been able to rejoin. Try pinging her a message. Might be having some technical problems.
Yeah, I see Henry's now back now, which is good because the first couple of questions are going to be directed towards him. So we'll give it one more minute.
Oh, fantastic.
We'll get back together.
And are those questions in the chat there, Reese?
They're in. We've essentially set up a Google form, so all the participants the questions, and I've aggregated them together. We've had quite a few questions, a lot of them along similar lines. So I'm going to try and draw them all together and hopefully cover as much ground as possible.
Yeah, Reese is taking over from here.
Any news from Laura, Ed? Or should we keep on?
I haven't seen anything. Yeah, I think Laura has actually rejoined.
Perfect. In that
case, in the meeting. In that case, I'll stop presenting, shall I? I'll let you carry on.
Okay, so yeah, this is the Q&A session. Please do feel free to keep submitting your questions. But the first couple are for Henry, and I'm going to link two together here. The first question is the case for the SMRs as part of the energy mix good enough? And also, is it good enough to convince the public, which is a key point we've discussed already? Similarly, what is the role of nuclear in decarbonising industry like steel? We've talked about cogeneration. So if you could kind of wrap all of those in together into a quick summary of what is the business case for the SMRs.
So the SMRs, small modular reactors, they are about 3/4 the size of traditional PWR reactors, the one like we're seeing being built at Hinkley Point C. So they're small in name, but actually the contribution in electricity to the grid is about the same as the current AGR fleet. So that's about 2% of UK electricity demand if they come online. But what's exciting about them is the sort of the financial attractiveness. Because they're slightly smaller, they will come with shorter build times and there's this idea of a modular aspect of building components off site, bring them on, and then repeating the build process across multiple sites. So you learn from the first build, and so basically the price will come down as you build more and more units. I think Andrew mentioned that in a similar thing when you went to offshore wind, with the first one being more expensive, that as you build more of them, you get better at doing it. So that's really why I think SMRs are seen as a way to get low carbon power reliably online in a short time frame. And that point about steel production, so I think someone mentioned about the Cumbrian coal mine, for example, being built, and that's going to be used for coking coal, I think, to produce steel in the country. And that's actually the fact we had to open a coal mine really says, well, there's a big part of the energy wheel there that we haven't decarbonised. So coming up ways to, around cogeneration, so flexibly using nuclear power to produce hydrogen, for example, for electrolysis, or if it's higher temperature outlets, you can get higher efficient production of hydrogen. And you could perhaps use that hydrogen for steel production in future, or go directly to industrial heat and getting that outlet straight from nuclear reactors, because effectively a nuclear reactor is a giant kettle, and you're just boiling water to produce steam. So why waste all of that heat just for electricity when there's so much more we can do with that, like as you mentioned, industrial heat for steel and other things.
Perfect, thank you, Henry. And yeah, any further details you want on that, I did the interview with Henry last week, and that's available on both the Jeff and the COP26 and Beyond websites. We're now going to try and go to an attendee. Sam, if you'd like to turn your camera and microphone on and ask your question. Let's hope this works.
Hello, can you hear me all right?
Yep.
So I know we've kind of discussed already quite a little bit, but my question aimed within the scope of what the Chancellor outlined yesterday in the new budget outline and the proposal for the new UK economy. So I'm just wondering what the kind of lessons we've learned from engaging with politicians and from these discussions, especially around the wind farm plans, and in what ways we can kind of improve upon this and how we engage in shaping that policy to align with the financial, ethical and engineering plans of the future.
So if any of our panelists would like to jump in, Yasmin possibly to lead off on that.
I thought that might come to me. It's quite a big question, Sam, so I might not be able to answer all of it, but I can maybe talk about the area that I work in. So I work on energy innovation, and in the budget yesterday and also previous to that, there was an announcement of a £1 billion energy innovation budget. So that's what myself and my colleagues will be working on going forward. And the whole point of that money is to develop the innovative technology that we need to help us to get to net zero. But I guess there are lots of wider policy issues. So if I pick on hydrogen as an example, it's obviously quite a big topic at the moment. Everyone's really interested in it. And within government, there are quite a lot of work streams. So for example, there will be a hydrogen strategy published later in the year outlining the UK's plans. There is another team working on hydrogen business models. So we know that hydrogen is more expensive than using natural gas or alternatives. So there's no incentive for people to use it. And therefore, government needs to step in and put in place some kind of subsidy to encourage its use. So yeah, that's another work stream. There are also lots of practical issues. So we talk a lot about low carbon hydrogen, but what does that actually mean? So there's another piece of work looking at standards, so defining what that means in a kind of quantifiable way. So that and all of those bits of work feed up into the ministers, and they're kind of driven by the overall strategies and the ministerial decisions. And I don't know if that answers your question, Sam, but maybe gives you a bit more of an idea of what's going on within government.
Yeah, it does. Thank you. Yeah, I appreciate it's a nasty question. That does give a very good idea. Thank you.
Okay, thanks, Sam.
Can I add something, Rich, to this? I think we've been primarily talking about energy, but energy is only part of it. But if we stick with energy for the moment, I think it's important to realise that energy is political. I mean, there's lots of talk about markets and so on, but basically we make a choice of how we want to make our energy, and then we do it. And that choice might be that we build new nuclear power stations. It might be that we do something else. But it's essentially political, which is why earlier on I was saying I really wanted your generation to get much more politically engaged in this whole debate. But I think we've seen something in the last year with COVID, which we need to consider very, very carefully. So before COVID came along as an urgent matter, everybody agreed, really pretty much across the board, that climate change was the biggest threat to our society globally. And yet we really haven't done very much. And then COVID came along and produced some quite extraordinary political changes. So we have all been happy to be subject to really major changes in our society, major changes in our freedom for the good of a particular cause, which is to prevent the spread of the COVID virus. Now, if we really agree, and politicians will always say that they do agree, if they really agree that the climate change is something important that we have to tackle, then we have to take the same sort of approach that we have to COVID. So it's all very well having plans for the future and innovation and studies and whatnot, but actually we've got very, very little time left and we need to do stuff. And the reason why renewables has been so extraordinarily successful in Europe is because a long time ago, about 10 years ago, we were told to do it. And if we didn't, we would all be severely punished. And we did. And we need now to do the same thing with other parts of our society, like transport or heating. So it actually matters not what we're going to study and do in the next 5 years, but what we do now. And we actually have the tools to do an awful lot of stuff, and we should just get on and do it. So I'm afraid in my older age, I become increasingly less democratic and more dictatorial. And I think we need to have some very clear rules about how we all behave in our society, like we have in an extraordinary way with COVID. If we apply the COVID approach to climate change, then we might actually get some things done pretty fast. And then we do need to do things pretty fast. So now is the time, and maybe the Glasgow COP is the time to really do that. And we could show the way with some pretty strict, maybe even quite brutal rules about how we all behave on the back of COVID. It's philosophically and ethically, maybe it's a difficult thing to do, but if we really agree this is the biggest challenge to our society, then we need to do something about it, and the COVID could be a good model.
Excellent. Thank you, Andrew. We've actually got a number of very young engineers, including myself, on the call today. And we've got a lot of questions about how we as young engineers can be better positioned for the digital innovations that are coming to various industries. So I'm not sure, Thaddeus, if you'd like to lead off on that.
Yeah, I would say what it's good to do is to think of what the problem is, you know, because digitalization, it's a tool. It's you need to use it to do something, right? So if you start thinking about the things that you could do better if you had this, then you've got those problems, you've got those kind of things, issues. Sometimes it's not a problem, it's just an opportunity to improve, to be more sustainable, to progress, and then go backwards, you know, and then find, and in this, if they haven't invented it yet somewhere in the world, you know, when you approach some of these companies, or, you know, people will start looking at it, because if people can make money from it, you know, and if people aren't starting looking at it, just start talking about it, start with a few friends, and then, you know, these days people are inventing, you know, world-changing apps and stuff like that without any formal education, you know. So if you start talking about it, start making a movement, someone else around the world hears about it, before you know it, the solution to your improvement point will be made. And so I would say start with actually the business case. What is it that you need the tool to do? And we need to start really looking critically at all the processes that we've got in our work, how that can be done better and going forwards, and how would we do it if we were to knock everything down and have to build it all from scratch today.
That's excellent. That's excellent. Henry, we spoke last week about the growing use of automation in the inspection industry in nuclear. Could you talk just a little bit about how that has changed over the last, say, 10 years?
Yeah, so I mean, I've been involved in projects myself. I go around the UK inspecting fuel and cooling ponds, power stations, and actually it was all pen and paper until quite recently for a lot of data recording, which just seems so archaic, really. And so, you know, getting digital that's the first step, and getting innovative, how you can do data processing quicker. You know, there's a lot of advances now in machine learning and using those algorithms for things like image assessment. So there's a lot of things, and that is an area that's key for collaboration as well. Is taking things from other sectors and saying, you've done that really well, let's take it to ours, and you know, and cross collaborating and sharing various ideas. But yeah, so it's an area we can all improve in, I think, and I hope that young engineers listening sort of see these big higher motivations that we're talking about here about the energy transition, and take that solution mindset they have to really apply it to that.
Perfect. Thank you, Henry. Anyone else have any thoughts on the role of young engineers in the digital innovations coming to their respective industries?
Yes, I think there are so many ways you can actually apply it in offshore wind as well, especially in the area of operation and maintenance. The industry believe that there are lots of roles digitalization can actually play, especially if you have digital data, or if you have a way of processing your digital data of what is happening in your asset, or how you operate it, or develop some tools that can actually help to optimize the operation and maintenance of the asset over the lifetime. That will really be helpful. There are so many things now they do out there that probably they don't need to go out there at the sea to go and see. If they can actually control things very much well from shore, that will help a lot. You know, see real time what is happening out there, so that whenever you want to go out for maintenance, you don't go there, for example, to go and check what is happening. You already discovered what is happening from your remote office onshore, and you're just going there straight to the whatever thing you want to do and do it. There are so many things already happening in this area, but I know young engineers coming up, they should be thinking in that direction. You know, there's always room for improvement, room for innovation, room for creating something new that would really help to do something like this.
Perfect, thank you. Any other thoughts before I move on?
I was going to say that any young engineer should learn to code, or everyone should learn to code. This is a very basic thing, because I think probably a few years from now, if you can't, it will be equivalent to not being able to read and write.
Absolutely, and I have to admit, I've noticed that just as an undergraduate, straight from the first week of a civil engineering degree, learning Python, learning R and C, very, very important skill. And a wealth of resources available at the moment online. Taking a slightly different track, we've had quite a few questions about how we're going to tackle the waste that is building up from our use of things like lithium-ion batteries for electric vehicles. And it seems as though we're replacing waste into the atmosphere with physical landfill waste. Not sure, possibly Daisy, if you'd like to lead off on how are we going to deal with this problem that's obviously coming down the line.
Yes, no, I agree. It is a big problem, and one that I don't know the answer to. We need to, basically, we need to do a lot more research on this. It seems it's a very political decision to be ramping up with electric cars so fast, but that it's clearly less in the public eye what happens later on down the line. And so when it's less in the public eye, this clearly also results in being less in the eyes of the politicians that are making the decisions. So I think that these sort of problems do really need to be shouted as loudly as possible to make sure that they're addressed when decisions are made.
Can I just come in on that? I think talking of waste, as people are probably aware, the nuclear sector is, historically didn't have a good legacy of waste. So I think we're probably prime example of just learning from those mistakes and don't repeat the mistakes that we made back in the past. And I think there's definitely got to be opportunities to collaborate there in terms of reprocessing of materials and correct storage and making sure those toxic materials that are coming from batteries and solar panels and whatnot don't end up how some legacy nuclear waste did end up. So yeah, I think it's really important that we assess the whole of the impact of the energy life cycle. Yeah, thanks.
Perfect, thank you. Any other final thoughts before we move on to our breakout rooms? I do apologise to anyone who didn't have their question asked. We did have quite a few, and I did try and bring some of them together at the same time. So any final thoughts from our panellists?
I think that this question is another one which engineers will rise to the challenge if they're told to. If we said, right, we're not going to have any waste, we are going to make sure we don't, sort it out, then there will be plenty of clever people, probably people sitting in this very audience, who would do it. And again, we're not so good as engineers in identifying the challenges. We're good at solving them. So if these problems are coming from engineers and then we also provide the solution, that will be a very good outcome.
Absolutely, absolutely. So we now have a quick breakout room session, roughly 20 minutes of more kind of close collaborative conversations with each of the panelists. I believe Vicky will be posting the links to the breakout rooms into the chat as I speak. Please do mute yourself in the main conversation before moving over to a breakout room so we don't end up with any interference.
Can people hear me okay? Yeah, okay. Brilliant. I'm hoping we have almost everyone back in. I hope that was kind of useful. It was a little bit just trying to get everyone in the right meetings, but I hope they kind of allowed people to ask some more questions a little bit more directly. Yeah, if we think we have everyone back in, I'll just go over the closing remarks and finish up here. I think this has been an absolutely fantastic conversation. A little bit more about my organisation. So I'm part of COP26 and beyond, like I said. I'm hoping you're able to see my screen. But we have a website and blog on there. It's all about the topics we've spoken about today and kind of more broadly than engineering itself. There's influencing politicians, a guide to the Paris Agreement, using the law to fix the climate, education opportunities. So that's all there. Please look out for us on social media at COP26 and beyond. We'll be running some future events, as one we'll be doing coming up on climate education, science and opportunity. We have some publications, one that's done, which is a guide to the Paris Agreement, and there'll be more to come. And the big news we have is that we'll actually be presenting at the Youth for Climate Summit in Italy in 2021. So that's the kind of pre-COP26 summit. Italy are the kind of partners of the UK in COP26. Where we'll be running 3 events using the law to fix the climate. This event, Engineering for the Energy Transition, and Climate Education, Science and Opportunity. So please keep an eye out for those. And yeah, feel free to follow our blog. Reese, would you like to do the next?
I believe I'll actually be handing over to Thomas Kavanagh, who's the founder and lead of Jeff, for some more details.
Yes, it sounds okay.
Yeah, that's fine.
Okay, yeah. So yeah, we initially founded Global Engineering Futures back in October 2019. and we've grown to over 100 volunteers from at least 25 countries in just over a year. And we aim to address like 3 problems, one of which has been covered a lot in this event, which is about collaboration. And so like the first point is just say thanks to all the collaborators. I think we got brought together 9 different organizations, including European Young Engineers, COP26 and beyond, E2E, Fuels on the last slide as well. But yeah, I think collaboration isn't really it's not something that we should be getting benefit from, but it's actually like an inherent requirement. And through this collaboration, we've reached attendees from over 30 countries. And we've also set up the Global Engineering Network to further propel collaboration and to help increase inclusion and diversity within initiatives. And so if you want to join that, you can participate and go via that link for jeffcic.com, where you can apply to be a member of that. And currently we aim to have around 100 countries involved in this. So it's a real great opportunity to, if you want to meet engineers from any country, any demographic, any discipline, then you should apply to that. And the second problem the Global Engineering Futures will address is the lack of diversity in the existing initiatives, which I mentioned. And finally, the real urgency to address current sustainability challenges, which I think as young engineers, as early career engineers, we don't fully appreciate. And often this gets confused for climate change or green energy, when in fact, sustainability is a much broader thing. And the next event we have is actually on the International Women's Day, diversity inclusion being one of the Sustainable Development Goals. And so Vicky, I don't know if you want to say a few more words about this event that you're hosting.
Sure, thank you, Tom, and thank you for the conversation that we've had today. I really enjoyed listening on to everyone, and I just wanted to invite you all to the event on Monday, where we're talking to engineers, entrepreneurs, and policymakers in different industries, from health tech to environmental policy. We have lots of collaborators joining us, so I'd love if you could also join the conversation. So check the link in the chat. So thank you.
Yeah, that's it from me. I just want to, thanks again to all the people. If you are interested in collaborating on any upcoming events and joining this group we've got together so far, then please just there's a space on the website to email us if you are interested in that, because it'd be great to bring together more organizations and therefore more people and really widen that discussion out. But yeah, thanks.
Brilliant. Thanks, Tom and Vicky. That's great. Yeah, everyone should go check out them. But last slide from me, I'd like to say thank you very much for Reese for helping co-host. Sorry, Joe, we've got a feedback. But just as I mute you, I'd like to thank you very much for speaking. Thank you, guys, all our speakers. It's an incredibly interesting conversation. I really enjoyed it, and it'll be open for everyone to watch later as well on our websites. And thank you to all the organisations that helped put it on: European Young Engineers, E2E, YGN, IChemE. We've got some more added on there as well, the Green Programme, and Yes Europe. So thank you all very, very much.